Hi, it's Todd of Todd's Workshop and Todd Cutler here. And today we're going to talk about this, which is a 14th century munition grade crossbow made by myself with a faux composite, a fake composite bow. Fake is a bit of a dodgy word, I know, but I'll explain what I mean by that. So basically, around about the 1300, maybe 1330, steel crossbow limbs started to come in. Before that, they were wood or they were composite. Now, composite is a mixture, it's components, two components put together, which is horn and sinew, and then obviously the glue to hold them together, and then a waterproof outer covering. Now, those bows were very powerful, very fast, but very, very labour intensive to make. So the steel ones came in, I suspect, I mean none of us know, but I suspect really because they're virtually maintenance free and they're very reliable, and once you get one working, as long as you don't overdraw it, it's basically going to stay working. Yes, they can fracture, but so can a composite bow. The injury you're going to get off a fracture off a steel bow is higher, but you know, if you overstress them during manufacture and then the actual draw length is lower during use, the chance of you actually getting an accident are fairly low. What I would say is, in the modern context, when I make bows, the steel is much better. It's a homogeneous steel, it's computer controlled on the heat treating. I treat them so that they will bend, not fracture. So my bows will not break. Historically, that was not the case. But coming back to the horn and sinew bows, they are very difficult and very time consuming to make. I don't know how to do it. If I could do it, would I do it commercially? Probably not, because the amount of time involved, you're never going to get that money back. So I stick with steel bows. Now that's a bit of a problem, obviously, if I go back into the 14th century, because certainly at the start and a long way through the 14th century, and even really into the 15th for sort of Central European bows, they didn't use steel. They tended to use composite. So what I've done here is I've taken a steel bow and I've clad it with some wood and then an outer covering to make it look like, or reasonably like, a composite bow. This way it allows you to get a bow at a reasonable cost, good reliability, and reasonably good performance. There is a slight drop on performance because you've got an outer covering with some mass in it. Now, if we come back to the composite bows as they were, because the glue that they use is usually a fish glue, swim bladder glue, but the glue that they use is not proof against water, so you have to keep moisture out of it. And I wonder perhaps why they weren't so popular in England because of that reason. Although Germany's not too dry either, but for whatever reason they were never enormously popular in this country. But it does mean that you have to have an outer covering to keep the moisture out. Now in this case I've used a waxed linen. Very often on even on military bows you get beautifully painted and beautifully finished bows, but this is a munition grade bow. This is made to a price. It's made to a price now, but it's copying the ones that were made to a price back then, and so the super fancy decoration wasn't there. But if you do want to see some extraordinary composite bows, modern ones that are made and used, there's a guy called Andreas Bichler. You'll find him on YouTube. German guy, never met him, don't know him, but his work is extraordinary. So go check his stuff out. So if we come back to this bow, we've got a Nash stock, very plain, and these sort of munition grade bows from this period really were quite plain. They're almost like they're sawn out of a plank. A couple of side plates here, cheek plates, which reinforce the whole lock area and the trigger system. One of the reasons for that is the nut is obviously eccentric, and an eccentric force, it vibrates as it goes around. So without the plates here, this area is quite susceptible to chipping out. Then we've got a bone deck on here, a bolt groove. The customer requested that on this. Linen string, hemp bindings, and a stirrup. Again, the stirrup is a slightly later design than I would usually put on this period of bow, but it's what the customer wanted. Now then we have these two lugs here, and these are for a goat's foot lever. So this bow here is running around about 470 pounds, something like that in draw weight, so that is 220, 210 kilos. I can't pull that. I could never pull that. But with the use of a goat's foot lever, what I am able to do is use the mechanical advantage. I've got another video on these actually, which explains all the different spanning methods. But I can do that and pull it back. And you can see here, I'm actually suspending it on one finger at that point. So that allows me to draw the bow. Now what this guy also wanted, because the goat's foot lever was around, but in the 14th century spanning belts were also around, he wanted this one set so that it was able to use a spanning belt. And that is what this little lug at the back here is for. So I'll just show you the detailed parts again. So if we start with the bow here, you can see that it is quite thick. Composite bows were thick. We've got more of a 15th century style stirrup at the front, hemp bindings with a sort of standard tensioning knot that you have there on crossbows, steel cheek plates, trigger, fairly straightish bar. 14th century crossbows had fairly straight trigger bars on the whole, and you can see again the stock is rather boring. And then at the back here we've just got the little lug where the spanning belt connects. I'll show you how to span this with the spanning belt in a moment. But going back now, so the spanning belt is here, so it's tough. It's 3.5, 4mm thick leather, nice forged steel ring, hemp cords, and then a doubler pulley. So that eye there is what loops, hangs on the peg on the stock. Now the doubler pulley, that is important because, as I said, this thing is around about 470 pounds in draw weight. I can do it with the goat's foot lever. I cannot span this by hand, and I cannot span it just with a regular spanning belt. I can draw around 200 pounds in draw weight. I'm not a bodybuilder, but I'm an active guy. Yeah, with some practice I could probably do a bit more. I'm 200. With the spanning belt I can get up to about 250, 280, maybe a little bit more. Never really looked, to be honest. And spanning belts no longer just rely on your back muscles and on your arm muscles. They now rely on your leg muscles as well, because you crouch down and you stretch up. So you've now got your whopping thigh muscles and your back muscles coming into play, and even your arms a bit. So you can, with a spanning belt, draw more than you can just with the regular hand span. That still is going to get me nowhere near the 470 pounds of this bow. So what you then have is a doubler pulley. Now, as we all know, a straight pull is a 1-to-1 ratio. With the doubler pulley, you have got a 2-to-1 ratio. So you can draw twice the weight that you can draw without it. The disadvantage, and I'll show you this in a moment, is that the movement you have to go through is much bigger, because of course you've now got twice the movement needed than if it was a straight pull. So they're a bit awkward, and I don't particularly like doubler belts. I don't like spanning belts at all, actually. But they were effective, and it means that you can use it now to get up to, I guess, if you're practiced, maybe 500 pounds in draw weight. But you might think that it would be a straight 2-to-1, but actually it's not quite that way, because these have not got proper bearings in them. Okay, they're just running steel on steel, so you do get friction losses in these doubler pulley systems. So I'll reset now, and I'll show you how it's loaded standing up, because that's the way you do it, with a goat's foot lever and with a spanning belt. First up, I'm going to show you the goat's foot lever. So with that one, what you need to do is set the nut so the teeth are just slightly down, because it's the string striking the back of the nut that rotates it around and locks it in position. So just opening up the goat's foot, putting that in the crease between my body and my leg. Nice positive lock on the trigger. Now for the spanning belt. So first of all, the buckle goes at the back, but you can't buckle it up. So it needs to be tight, it needs to be high above the waist. Buckled up. Now you can twist it around. And this, of course, rather inelegant looking object, it's very difficult to run in it. So imagine if you're a crossbowman, the first thing you'd do if you had to run was to ditch your belt. Now previously, the nut is in this position here, right? That's how it works with the goat's foot. But this time, you need to engage the nut, and you hook the cord over it, hook the string over it. Now get it on, get it central. Then what you do, you hook your foot in, give it a little pull, hook your foot in. You can push down there, And the whole thing, and we're in. So as you can tell, I'm really at the limit of what I'm able to do. So that's it. A 14th century faux composite munition grade crossbow. Faux composite because it's got a steel bow in here, but it's made to look pretty much like a composite bow. Thank you very much.